How about now?
It is still low. Your voice is not clear. That means not able to hear you properly.
Hello, how about now?
It is same.
I'll
This
just
conference
quickly,
will now be recorded.
I'll quickly share my screen. So here I'll just take a few minutes, to walk you through so what exactly the full stack observability and how why we need this full stack observability and what it makes to go forward with observability and now it is being implemented with Grafana. Uh, as we know, currently, the everything is like in the digital world. Okay, so when I say digital world, we are seeing the different types of applications. Some of them are the Kubernetes based. There are like you can see the applications are developed, the Swift based, and there are some applications landscape which are coming with hybrid model. There may be the front end applications are hosted on the Kubernetes, and whereas there are some applications which are still working from the on premise where there may be some legacy stack which are like kind of not able to onboard to the cloud. And if you can take, there are some other the technology stack where the private applications which are hosted on the private cloud where it cannot be exposed to the public cloud. And also there you can see the different applications coming from the AWS, Microsoft Azure, IBM Cloud, and also there are the various applications which have been onboarded. So in order to measure, the overall performance in terms of the different domains, from the business perspective, from the infrastructure, from the application perspective, from the synthetic perspective, and also from the networking perspective, you have to have the different the monitoring tools are to be worked in siloed. So that's where what happens is like if you have a tools in siloed where it is very the challenging in order to measure the end-to-end performance having a different tools in the market. So having said that, here is we are having a the observability tools which are called the Grafana Neural Lake. So what they do exactly, like once you have the agent is running on the different digital world, so where you can plot the dots right from the business, the till to the end user performance. And also you can easily measure from the IoT, the data center metrics you can easily pull, and the branch level metrics you can easily, the correlate and the put it on the dashboards. So this is about how the digital world would be there and why we need the full stack observability. So as we said, the observability. So when we talk in observability, it is something kind of like a practice or a method or an approach through which you are going to observe the application. Okay, using the metrics, the events, the logs, traces. So you may ask so what is the difference between the monitoring and the observability? So basically the monitoring is nothing but it just say like what's going on there. But whereas the observability it will say like why it is happened, why the failure it is happened. So that's where this approach, this method will come where you can instrument the application uh, from end to end covering up of all these four metrics, all these four pillars which are called metrics, events, logs, and traces. So that's where this full stack observability comes into the picture, so which will enable the customers from the monitoring to the full stack observability. If the customers is like having a complex environment with traditional IT environments, where the measuring the application performance is like a kind of quite challenging. So that's where this will come up. And their customers are struggling with the applications, the visibility, getting insights on the particular stacks from maybe managed and unmanaged. So that's where you can the bring in the full stack observability, so which you can get in visibility across all the domains which I talk about: the business, application, infrastructure, end user, security, and the networking. So all these six domains you can get like end-to-end visibility, and you can just correlate with to get insights from all the corners, and then you can take an appropriate action. Either you can like integrate with the third party systems to perform some operations, so that in order to bring your application back to the normal. So all these things can be performed with a single like observability tool, which is like a Grafana, Datadog, and there are like the Neuralink. But the Grafana like is kind of like which is like an easy to implementation, and with help of the Prometheus, which is a backbone to the Grafana, so which is kind of like goes with the time series database measurement, so which will give you like a the detailed insights and a good view of your application performance. And coming to Uh, so what are the gaps like that have been filled with this observability using Grafana? Okay, so for instance, you assume that there is no ability in order to get a complete the visibility of the single pane of view, where you wanted to get the complete the insights and visibility on the full stack across the various domains. As I said, right now, like there are 6 to 7 domains and the different data types. Okay, so that's where like we are bringing in Grafana in order to get a view on that. And also there will be a kind of like challenges where there are like certain cloud native microservices. Suppose if you take like an AppDynamics and the Dynatrace, so there are like still coming up to get a visibility, but there you need to kind of like have some lot of the custom instrumentation in order to bring those metrics, the visibility onto the dashboard. So that's where like this Grafana and the Neuralink will come into the picture to get the insights. And also there is a challenge around the getting the insights and correlate across the multiple stacks around the different domains. So that's where this full stack observability with Grafana will help. And also you have to have like a siloed monitoring in order to measure the performance of infrastructure, application, and networks. But once you have a Grafana in place, you will get like an end-to-end view across all the 7 domains. And also like you suppose if you take an AppDynamics or maybe Dynatrace to get a dependency on a third party system, because you have an e-commerce application. For example, you have a like a e-commerce portal, so where it is the making a call to the third party service during the checkout order, where it is making an Apple Pay, or where it is making a call to the Afterpay, or it is making a call to the Google Pay. So at that time, like you have to have like again write a custom extensions using an AppDynamics Dynatrace to connect the dot to the application dependency. But here, this Grafana like being a full stack observability tool, you will get like end-to-end visibility covering up a third-party service with the dependency performance in terms of resource utilization and in terms of like the response availability, the response time, the throughput. So all those like metrics which are dependent can be like easily shown using a Grafana. And also the for the last but not the least, you can easily get extraction around the metrics, the logs, and also like it can easily integrate with the third-party system, as I said earlier, like as part of actions, which is like a third pillar of observability. The first pillar will be the overall full stack observability. The first pillar would be the visibility, where you'll get a the view across all the six domains. And next, the next thing is an insights, which you can easily correlate the, the performance across all the six domains. And the third pillar would be the actions. So this will give you like what you are going to do next. Once you see any the performance deviation or the service is like not performing well. So that's where like this integration comes in, in order to do for AI ops, for automatic the root cause analysis, or maybe like the self healing, where you have to have like write a script by you calling an Ansible tool, so that it will just go and it will just perform some operation so that it will heal automatically. So these sort of like things which can be easily resolvable by having this in place as part of this. So this is like one of the key pattern. And whenever we are monitoring an application or any system from the observability standpoint, so what are the best practices so that need to be adopted so in the beginning? So ensure like we are what are the microservices, okay, so that are being like deployed on the individual cloud services in terms of like token management, telemetry, app management, and API management, where you'll have like the security, the certificates, and all those details to be captured properly. And also the messaging, so there will be some message brokers which will be deployed in order to the talk between the different systems, either like Apache Camel or IBM WebSphere or whatever the messages are there. And also like ensure like each the metrics at the container and the cluster level to be captured. So that's where like you can easily troubleshoot the system. And also you'll get a the basic the level of network monitoring. What are the requests going, what did the data level, how much it is traffic is going out in, and what are the transactions which got impacted due to the low traffic. So those details like which needs to be captured well. If not, like you have to do some customization to get this thing. And also ensure like the core components of an applications are captured well in terms of like the JVM from the Java perspective and the CLR from the .NET, and what are the virtual machines or the physical servers hosted. So all those all those components to be like monitored, so to get a complete view. If there are any middleware components involved, like EJB, or Mule, where it will the convert the messages from front end to the back end. And if you are having any GraphQL, where it will convert the front end messages to the readable format, to the downstream systems. So this is the one. And the databases, whatever the databases are there, so those need to be monitored. And another thing is then like the analytics, from if the business wanted to have like the high level view. If suppose if I talk about the Salesforce Commerce Cloud, let us say like what are the number of orders placed and number of payments and order to pay. So there are like certain use cases where the customer wanted to see at the business KPIs. So ensure like these four best practices to be implemented from the Grafana in order to the capture into it. So this I'll just take a pass. Let me know if you have any questions. Okay. So we are talking about this Grafana cloud. So right now we are seeing like this Grafana cloud is becoming kind of like an open source platform where it is kind of like a SaaS offer. It is coming in two propositions. One is like uh, the Grafana Enterprise, where you need to like purchase for the application metrics in order to capture an application and all the different stacks. And there will be a trial version available, which is called like Grafana Cloud. Uh, so it uh, doesn't have any like a couple of months version available. So basically, it comes with the trial version. So where it is uses in order to track everything like the metrics, events, logs, and traces. So this will give you about this is the URL where you gonna like access Grafana Cloud. And basically, like the Grafana cloud comes with the stacks. Basically, like these stacks are kind of like a storehouse. We can call it as a warehouse where this keep they keep database of metrics, logs, traces, the dashboards, and alerts for each team. Suppose if you're having like 6 to 7 departments in an organization, like development, testing, performance testing, and the UAT and the production. So that's where like we'll be creating a different stacks for each team, so that they have their own database of alerts, logs, and everything. So which will be easy to that. And this will help in order to cater the multi tenancy requirements for each product, so that they will have a different stacks which can easily distinct that one. And the stack URL is like identified by using the defined by using the stack name. Again, here it is a stack name is nothing but the different teams, like dev team we are having. So it is Isha dev team dot grafana dot net. And if it is a production, so there will be kind of like FO prod.grafana.net. So based on that, certain rules, users, roles, and groups will be created. So where this will be pertain to particular team where they can go ahead and access to that, and you make and where we can find those tags and URLs. So basically, like this will take you to the particular cloud. Uh, okay, so this is about like Grafana Cloud Stack. If you can look at because this is a trial version, so only one stack can be created. So once you land on this page, so here you can see like these are different tenants here. Okay, so I'm having this. So in this one, you have like you can create this stack here. The moment you just create the stack, you'll be getting these 6 to 7 components will be created, which are the key ones to Grafana. So this is like Grafana, where it will just go and launch the Grafana is kind of like a front end where it give insights and correlation of all the overall application. And Prometheus, this is main the backend, a backend one to the Grafana. So where it is like a metrics system, which it will scrape the metrics from the different application components and it will send it to Grafana. And again, the Loki, which is used for the log management, where it uses the prompt tail as an agent, where it will push the logs to the Loki, so that again this Loki will manage to show the log events onto the Grafana. And this is Graphite is like another metrics which is used for measuring the metrics. And this is alerts. This is used in order to it uses alert manager as a backbone to set up an alerts based on like monthly, weekly, or depending upon the different criticality of the application based on the thresholds. And this tempo is another component which is used to, in order to build the distributed traces, which will help in order to easily pinpoint the issue and identify the root cause for a particular event. Uh, and here you can set up, the policies and all those details. And you can also set up like the multi-factor authentication using here like OAuth2, where you need to pass like API, which will give this one. And if there is any issue occurs, you can just raise the tickets with this one, get support. And you can set up like a monthly, a weekly CMS, that is like the customer success meet, where this Grafana like partner manager will join, and he will try to coordinate with us in order to work on these tickets and try to resolve the issues. And this billing, so there will be like monthly billings will be generated. So based on like the metrics you have been like consumed, because this is like kind of a trial version. So you don't have anything, but by default you'll be getting like 1,50,000 metrics for the trial version. So once those got expired, you can kind of go for upgrading, or maybe you can go for to the enterprise Grafana cloud, so that you'll be having a monthly consumption of the metrics. So that's about this one. And so here it is talks about the one which are like grayed out in the blue. So these are kind of the permissions which we have to give at the developer level, operator, and the business level. uh, and here comes with the different roles. Basically, it comes with the three different roles: the viewer, editor, and an admin. So admin is having like full length permissions, where you can go and do manage and optimize the stacks which are like found to be any like duplicated. He will just go there and manage those them. And the editor is kind of he's kind of like go ahead and delete, play, and add, modify the dashboards, the dashboard panels. And if you wanted to add a new data sources, so those details you kind of like add a new panels, and all those details can be done. Viewer is something like this can be given for the developer, sometimes for the operators, the who are sitting in the level 1 and level 2. In the level 1, so those guys will be having a viewer role. Suppose if there is an issue occurs, so they just go in and bring up those dashboard on the screen, and they will try to see like this belongs to which application, which group, so that they just route that ticket to that event. So these are like various roles which Grafana provides, in order to optimize the permissions and the roles. As I said, that these are the different components which we just spoken earlier. So Grafana, which is a front end, which show the all the details. It comes with different plugins. So it has like the plugins for the database, for the third party systems, for the to establish like event management system in order to integrate with ServiceNow or PagerDuty, or it can also integrate with the Splunk ITSI, which is the Splunk intelligence, and the Prometheus, which is the backbone system for scraping the metrics to Grafana. The Loki, as I said, it is uses this prompt tail. Loki comes together to push the metrics, alert and alert manager. So this about like kind of the Prometheus architecture, which because the Grafana is kind of like just a web UI. Okay, so it doesn't do. It is just like a console, front end console. It's a completely the depend on these Prometheus, Loki, Tempos. Okay, if these components kind of like stop for sending the metrics, so Grafana kind of like that doesn't have any ability to show the metrics. So having said that, it kind of like comes with the three different like uh, parameters. So here this is the targets. So based on like this is the main the components where these things will be used in order to uh, like expose the metrics. Okay, so these are like a web app will expose the metrics. Linux VM will expose the metrics from the resource level by using like an exporter plugin available, and API server which is having like the client library. There are like client libraries which will be used by Prometheus, so that they will try to scrape those metrics from the web and application level and expose to Prometheus. So that's where they can be like presented to the Grafana. MySQL D. This is like an exporter which is used in order to scrape the metrics at the database level. And also, once you have this Prometheus, which uses the time series database, it is nothing but a timestamped data. So where it is having like all the like the time to time metrics available in the different phenomena, like summary. You will have like buckets and all those different palettes you will have in the database. And coming to this is like the service discovery. So once you have this Prometheus running as operator on either any of the Kubernetes, so this what happens. So it will just start once you expose this Prometheus metric to Prometheus operator to Kubernetes, AWS, Google Cloud. It will start like they are capturing the metrics and then send it to Grafana. Basically, it works on like the pull and push mechanism, so that it will pull the metrics from the different cloud service providers, and it will send the metrics to Grafana. So that's where like they've just given this. You can just use this to collect storage processing, and this Grafana is a web UI which uses the dashboard metrics. So these are like some glimpses of uh, the Grafana. So how we have to use this? Okay, so this will give you. This is like works on an YAML based, where everything like you have to mention for the Prometheus, from the Loki, for Tempo, for Grafana. For all these agents, you have to use this YAML file, which will like use in order to go ahead and deploy agent on particular Ubuntu, Debian, or whatever the Linux systems are there. And this is the like the format where we have to use the indentation. This is the node exporter which is used in order to expose the metrics at the node level, and you have to use this Prometheus API. This will use in order to the pull the metrics which is sitting on the particular application and expose it to that. And this is the Loki. You have to mention what sort of the logs you wanted to expose, events which will be displayed to the metric, displayed to the Grafana. And you have to everything will be denoted in terms of the job names, where you wanted to have like different log files. You wanted to separate, discriminate those different things, where you can mention by the job name, which under the script configs, what are the targets, and all those details will be given. And this one will help you to show the Prometheus metrics. Once you just have this URL up and running, then push the metrics, it will just come up here. And these are some glimpses of Grafana dashboard. So this will give you about the resource level, and what are the errors at the application level. Those will be given here. And here this one uses the Loki in order to scrape the logs and show it on this. This is about the application level metrics of how this application performancing over a period of time. And if you look at the lower left corner, this is about the Prometheus. So once you expose the Prometheus using an operator-based model, it will start like showing the metrics for a resource level application and all those details. I'll just take you to this demo here. Uh, yeah, unfortunately, I'm having some challenges here, so I've just drafted that in the document. So I'll just run you through this one. So basically, I've used to build Hello World. I've taken an Hello World application. Just build the workloads on Azure Kubernetes. So that's where you can see it. Like it is running on the two parts about this Kubernetes. Uh, and this is once you log in to this the cloud shell. So this is kind of series of the commands which you have to run it across to just enable the uh, Hello World application, and at the same time um, the Grafana. So I've created a couple of namespaces so differentiate the application and the Grafana. So then this is the definition file which I've used to onboard the Hello Spring Boot, where I've used the micrometer because the micrometer is playing a major role where you have to give this configuration under the pom.xml, so that this will just go there and it will start sitting on top of the JVMs, the microservices JVMs, and it will just get those metrics at the application level in terms of request count, errors, response time, 95th percentile. Okay, so all those metrics like from the application level, which can be easily the exposed and presented to the Prometheus. So these are about like two definitions file which I've used to expose these. And uh, uh, this is about the deployment file. So used to just get this, and once you have to run some couple of commands to see like whether the all pods are running in on it. Okay, so we have like this deployment, the pods, uh, the services, and the replica set. So I've used these two replica sets. So using this external IP in order to get the application to be displayed on this. So once you have this application up and running, just checking it like whether it is the metrics endpoint is properly working or not. So that can be tested by just using, because this 8080 the uh, Hello World application to be exposed 8080 port number. So once you have done, then slash metrics so that you can see the metrics at the JVM level, the request, the success, you'll get success, fail, you can see like here 200, and you can see here 404, how many requests have been done. Then coming to you can get like seconds, how much time it has been taken in order to load. So all whatever the metrics like which the leading APM tools are being exposed, all those metrics kind of can be seen from Grafana. So once you have the application is working fine, the metrics is exposing. So now it is a time to onboard Prometheus locally. So here we are using. There are multiple ways to do that. Here we are using the Helm repos, which is like a standard practice, which is like a standard built-in template where you are having all the details about the role binding, cluster role, all those configurations will be available. So to do that one, I have like kind of added this the Loki, and another one is like the Prometheus. So they are available from the Loki. This one. So once you have that one, you need to run this certain set of commands, which you can see it on this Helm repo add. So then you can need to update the repository. So once you have done that, you need to You need to like there is another one repo Prometheus. This is chart start Prometheus.sh. So added that into the monitoring so that it will just start like deploying this operator, and at the same time the node exporter, so which will help in order to get the metrics that will be scrape and the push to the Grafana. And this is an alert manager which will help in order to set up our alerts based on the conditions for the particular application and for the particular resource, or across the different domains like the business application infrastructure security network. Okay, so all those, in order to set up the alert conditions, so you have to have this alert manager which will help. Then it will also like load up this Grafana, which is a front end console, and it will help the cube state metrics, okay, which will help in order to get all the Kubernetes the metrics to be exposed here. And once it is done, so we are using this SVC, service monitor. Basically, this will help in order to scrape its metrics to the Prometheus. Of course, there is a micrometer is there, but the micrometer kind of like it will just get application metrics, and it will just help to show them. So here we are using this service monitor, which will do like automatic discovery of the applications. Then it will show the metrics to the Prometheus, and it will send it to the Grafana. So here it is the definition which we have used to just pull the details. So once we have that, we'll be running this service monitor. Once you have this Grafana Prometheus parts are available, you need to expose those metrics, which have used this expose part Prometheus operator under the port number 9090. And this Grafana is by default available at the 3000. So here we have to have used this imperative commands to just expose the metrics. And I will be checking it up like whether this all these services are available to the external world or not, so that we can do it with the kubectl get all. So once you have that, so this is the first glimpse of the Prometheus, where it will show about the different details. And this is the Grafana, which is available under the 3000 port number, which is easily exposable. So once you have that, you can see like as we have used this service monitor in order to scrape all the application metrics, infrastructure metrics. So once you have that, you can see this. These are all whatever it is residing on the particular Kubernetes. All these details will be available here. This Kubernetes control manager, cube state metrics, node exporter, Prometheus, hello world. So this is an hello world, which is the two microservices which is running on it. And once you just expand this, you can see that what are the metrics it is able to get into this. Okay, so it is giving the namespace details, what job it is running on it, and what is an endpoint it is exposing the metrics for each for those two parts, which we can see like and how long it is been running. And and also like there are some default the Prometheus uh, uh, metrics. This is like Prometheus query language metrics, which we can call it as formal. Here it uses like what is the CPU. If you can see that these are the two nodes which I've tried to get. Right now it is like kind of the five and one. You can see these are like on 1058 milliseconds. And suppose if you wanted to validate the CPU, number of CPUs it is available. So where there are some default things which you can do that. And what are the maximum response time, which again is these two parts, which you can just get into this. And if you wanted to find out this container level of metrics, okay, so yes, you have to run this command by giving a butler namespace, so which it will ready to scrape this one. And these are once everything is in place, once you have service monitor deployed, and once you restart all the Grafana Prometheus, so then after a minute or two, it will just start the getting metrics at the CPU level for each part, which you can see it here. So this is the CPU, and this is the memory and the core level, number of cores and all those details. And this is like the resident memory, which will give you like how much uh, how much memory it has been used. All those details will be getting into it. And this is about the 404 annual dashboard, and this gets the insights on response time against these two parts over a period of time, how the server application is running. So once it is done, like as we have installed this Loki, I've just repeated this help charts. And by installing the Loki, it is not enough, to get the things. You have to have a prompt in, which is an agent which pushes, the logs from which are residing on the server to present it on Grafana. So to do that one, you have to add this data source. Once you have that, okay, so this is the steps which we have to do that. Okay, so we need to just add Loki hello world, this hello world script, so that it will just start showing these metrics, under this completed 200. Okay, you can see all those details. This is again logql. This is a Loki query language. There are like certain queries which we can use it. So it will give you all the details about errors and all those details. Uh, so coming to this, once we have this, okay. So these will be like a the curriculum which we will be discussing about, like how this Grafana can be installed, what are the advanced components in that, and how we can like alerting at the same time, how we can AOps. Grafana has its own like Grafana on call, which is kind of like can work as an AOps. How we can set up so to just to do the self healing, how this Prometheus, which will work to set up this one, how we can integrate with databases, different databases. We can integrate with the LoadRunner, we can integrate with Jmeter, InfluxDB, MySQL, and ELK, AWS, CloudWatch, AppDynamics, and Dynatrace. If you wanted to get certain application insights from the AppDynamics to be show it on Grafana, and also this, and during the load test execution, if you wanted to perform any uh, in order to measure the performance of a particular application during the load test, those insights also which we can get these things. So that's all from my side. You have any questions?
Yeah, just a quick bit. So how long is this course now? Is the training?
This will be like yeah, 20 hours.
So every day is 1 hour?
Yeah.
Okay. So just wondering. So you said you have like 17 years experience in the IT world.
Yes. 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 Yes.
So you're more into SREs?
17 into overall IT industry, and from the last 6 years, I'm into like performance engineering and SRE.
Oh, okay. I'm
But
just wondering. In SRE, what did you really do?
sorry.
Is it more with SRE?